Hi guys, I'm going to explain you about exact equations and how to solve them. If you want to know where does this solution came from, then you will have to watch the video in the description. The link is going to be there. So an exact equation is characterized because it is written as some function of x of y dy f x of y multiplying dx plus some other function of x of y multiplying dy equals to 0. Okay? Now, in order for you to know if you can use this formula, then after you have this, you will have to check that m of y, m derived by y, it's equal to n derived by x. So, if you remember in our video about notation, this will be the same as having the d over dy of m of x of y, it's equal to d over dx of n of x of y. Okay, just making sure that you hadn't forgot this. And now we can solve this in two different ways. You can choose a way on however you find the equation the most simple, okay? So we have two formulas. The first one is we integrate m through the x, so we integrate this term, and then we add the integral of n minus the derivative of dy of the integral of m of x, and all of this integrated by dy equals to c. I know it looks kind of tricky, but I'm going to show you some examples so you will be able to understand how to use this. But so far, so this term and this term are the same term, okay? And then we have the n that came from here, and that's practically all. And for the other one, if you decide to use n instead of m, so we integrate n by d of y plus the integral of m minus the derivative of x of the integral of n dy times dy, it's equal to c. I know it looks kind of scary, but it is not. It is in fact quite simple to use. So let's go to some examples. So let's see, for example, this equation. So we have 2x minus 1 dx plus 3y plus 7 dy, it's equal to 0. So our first step is to know which one of these functions is m and which one is n. Okay? So because this is multiplying dx, we know that this is m and this is n. It's multiplying dy. Okay, it's already in this fashion. So next is to put m of y, it's to check if m of y it's equal to n derived by x. So we derive this by y. So d of 2x minus 1 over dy, it's equal to 0 because there are no y terms in here, so x is like a constant for this. And then we have the derivative of 3y plus 7 over dx. There are no x in here, so these all are constants for this, so it's the same as having a 0. So 0 is equal to 0, and now we can use this method, okay? So let's plot it in both equations, so you will see that they will lend you to the same result. So we will first have here the integral of m dx, that is going to be 2x minus 1 dx plus the integral, now it's n, so 3y plus 7 minus the derivative over dy of the integral of 2x minus 1 of the x, and all of this multiplying dy, it's equal to c. Okay, there is a constant. Sorry, there is a constant. Now let's solve. So the integral of this for dx, so for the first term we will have x squared minus x, so very easy to solve, plus the integral of wherever 3 of y plus 7 minus, now this term is the same as this one, so we just know that this is one, and if we derive this by y, so if we have x squared minus x, and we derive this by y, so because there is no y terms in here, so all of this goes to 0, because to this equation this x is the same as having a constant, so it's a 0, so it's minus 0, and all of this multiplying dy, it's equal to c. So now we have to integrate these two in terms of y, so we have x squared minus x, plus we integrate this one, so it's going to be y squared 3 over 2 plus 7y, it's equal to c. And this is our answer. Okay, now let's check what happens if we use the second formula instead of the first formula. So let me use the other side of this. So I will rewrite the formula for you. So we have that the integral of m dy minus the integral of m minus d over dx, the integral of n dy dx, it's equal to c. And our equation that we're checking, it's 2x minus 1 dx plus 3y plus 7 dy, it's equal to 0. So let's just check it out, so you don't forget that this is like this. So it's here, and our formula is here. So there are no errors, there are no mistakes. And now we will have to plot everything inside. So we have that the integral of n, that the n now is this one, so it's 3y plus 7 to the y, plus the integral of our m, that's going to be 2x minus 1, minus the over dx of the integral of our n, so it's 3y plus 7 dy, and all of this is multiplying dx. Okay, please just wait for a second. My pen is dry. Dx, it's equal to c. So now first we integrate these ones, so we have y squared 3 halves plus 7y, so this is this term, so this term will also be here. So if we derive this term, if we derive this function in term of x, we will have a 0, so we know that these terms become 0, so we have the plus integral of 2x minus 1 minus 0, and all of this times the x. So now we have to integrate, it's equal to c. Now we have to integrate this one, so we have 3 minus 2 y squared plus 7y, plus now we integrate this one, so it's x squared minus x, so this one's his, this one's his, it's equal to c. Okay, so this one happens to be exactly the same as this one, right? Yeah, no changes, so you can use whatever equation that you want, whatever you feel more comfortable with, but remember to always check which equation will make your life easier. Okay, so see you next time, and you can see more videos for another example, and then I will show you some other things about this and how to normalize a not normal equation. So please subscribe and thank you for watching.